Michel Bitbol, a prominent philosopher of science, explores the relevance of Immanuel Kant's philosophy in modern physics, particularly in relation to quantum mechanics and the nature of scientific understanding. Bitbol's interpretation of Kant emphasizes the idea that scientific knowledge is shaped by the conditions of human cognition and the structures we impose on the world to make sense of it. Below is a detailed explanation of how Bitbol connects Kant to modern physics. 1. The role of a priori structures. Kant argued that our knowledge of the world is mediated by a priori structures, such as space, time, and causality, which are not inherent properties of the world but are imposed by our cognitive faculties. Bitbol sees a parallel in modern physics, especially in quantum mechanics, where the observer's framework plays a crucial role in determining what can be known. For instance, in quantum mechanics, phenomena such as wave function collapse and uncertainty are deeply tied to the measurement process. These processes suggest that the act of observation itself shapes the outcomes, much like Kant's idea that perception is structured by the mind. The formalism of quantum mechanics involves abstract mathematical constructs, like Hilbert spaces, that are analogous to Kant's synthetic a priori categories. They do not describe the world as it is but provide a framework for organizing our experience of it. 2. Rejection of naive realism. Kant rejected the idea that we can have direct access to things in themselves, noumena, and maintained that we only know phenomena, the world as it appears to us through the lens of our cognitive structures. Bitbol applies this insight to quantum mechanics, which challenges classical notions of realism. Key points include: quantum theory reveals that properties like position and momentum do not have definite values independent of measurement. This aligns with Kant's claim that what we know is not the world as it exists in itself but as it appears under specific conditions of observation. Bitbol suggests that Kant's philosophy provides a way to interpret quantum mechanics without falling into the trap of trying to explain quantum phenomena in terms of classical realism, which often leads to paradoxes. 3. Observer dependence in quantum mechanics. Quantum mechanics highlights the interplay between the observer and the observed system. This resonates with Kant's view that knowledge depends on the interplay between sensory data and the conceptual framework of the observer. Examples include: the Copenhagen interpretation of quantum mechanics emphasizes the role of the observer in defining the state of a system. Bitbol relates this to Kant's idea that the mind actively organizes sensory input into coherent experience. The complementarity principle, e.g., wave-particle duality, can be seen as an expression of the Kantian insight that reality is not fixed but depends on the perspective from which it is interrogated. 4. Limits of scientific knowledge. Kant acknowledged that there are limits to human knowledge. Bitbol extends this idea to modern physics, where quantum mechanics and relativity reveal the boundaries of what can be predicted or understood. For instance, the uncertainty principle demonstrates a fundamental limit to what can be simultaneously known about certain pairs of properties, echoing Kant's point that we can never fully know the noumenal world. Theories like quantum field theory rely on mathematical abstractions that do not correspond directly to physical entities but serve as tools for organizing experience, much as Kantian categories organize perception. 5. Constructivist perspective on science. Bitbol interprets Kant as offering a constructivist view of science, where scientific theories are not mere discoveries but constructions that allow us to make sense of the world. Modern physics, with its reliance on abstract, mathematical models, reflects this perspective. Quantum mechanics does not describe an objective reality but provides a predictive framework for phenomena. This is consistent with Kant's idea that science does not uncover ultimate truths but constructs models that fit within the constraints of human cognition. Bitbol suggests that understanding the success of quantum mechanics through a Kantian lens can help resolve debates about the interpretation of quantum theory by focusing on its role as a tool for organizing experience rather than a description of ultimate reality. Conclusion. Michel Bitbol's Kantian interpretation of modern physics emphasizes the active role of the observer, the rejection of naive realism, and the limits of scientific knowledge. By viewing quantum mechanics through Kant's framework, Bitbol shows that modern physics is not just about discovering reality but also about understanding how our conceptual and observational frameworks shape what we can know about the universe. This perspective offers a profound philosophical foundation for grappling with the counterintuitive and observer-dependent nature of quantum phenomena.